Okay, 2.5, functions. A function is a rule that takes an input called x, and from it computes an output called f of x, written with f parent x and parent. The illustration here is that you have two circles with x in one circle, an arrow denoted f pointing to another point in another circle called f of x. This circle here is the domain of f, meaning the all possible inputs for f. This circle here is the range of f, equaling all possible outputs. Now, there are an even number of functions, with various ones from time to time. Here's one function, f of x equals x plus 17. It's the function that adds 17. G of x equals 23x. It's the function that multiplies by 23. H of x cubed, that takes x and raises it to the third power. Here's j of x, 3 to the x, that takes 3 and raises it to the power x. Two very different functions. All right. The graph of a function is a set of all points with coordinates x by f of x. So if y is the second coordinate, then y equals f of x. Here's an example. Y equals x squared. It's an equation. We'll graph the equation, or graph the function x squared. It's the same thing. By taking a step in the middle. I make a table of values. Let x go through a few values, -2, -1, 0, 1, and 2. Y is the square of those, 4, 1, 0, 1, 4. And we plot each of these 5 points. Here's -2 by 4, here's -1 by 1, here's 0 by 0, here's 1 by 1, and here's 2 by 4. Well, that's just 5 points. And on a continuum, there are, of course, an infinity of points. But, the more points you plot, the more it gets. The more you get this U-shaped curve called a parabola. All right. Now, if you have a graph of a function like this sort of N-shaped curve, then its domain and its range can be found by projecting onto the x-axis for the domain and projecting onto the y-axis for the range. The domain is a set of all x values, so we project onto that. And this is therefore right here is the domain of that. And we project the point sort of find its shadow on the y-axis, and this is the range of that. All right. Now, if you have a function, a graph of a function, then for any x value, there's only at most one y value, f of x. Therefore, any vertical line corresponding to a specific value of x will meet the function graph in at most one point. That's called the vertical line test. For example, this wibbly wobbly thing, every vertical line will meet it once, so this is a graph of a function. Here is a graph of a function. Later we'll call it the, let's see, are we doing that? Yes, we'll meet it. It's called the graph of the logarithm. Each vertical line hits it at most once. For any vertical line where x is negative, doesn't hit it at all. The domain of this function is the positive x values only. Still, it is a function. Now this circle, it's a perfectly fine graph, but this y-axis line, vertical line, corresponding to x equals 0, it meets it twice. So this is not a graph of a function. This backwards s meets this vertical line 3 times. So again, not the graph of a function. All right, we have a number of functions that we'll be dealing with during this course. Here is y equals ax plus b. It's called a linear function because its graph is a straight line. Here's the equation y equals ax squared plus bx plus c. This is called a quadratic function. And I should end that quote mark. Change this in the original. Okay, and its graph is this U-shaped curve called a parabola. Is y equals x to the third power, cubic function. Its graph is a kind of N-shaped curve. And fun fact, where it goes to the origin point, the graph is, for the briefest moment of time, completely vertical, horizontal, completely flat. This is like in the old days when I would drive up to the Bay Area, the Bay Bridge toll plaza. I would zoom up and slow down to a stop for a fraction of a second, then zoom off again. Until one day it was a rolling stop, and the attendant said, "Hey, stop." Anyhow, here, y equals 1 over x. This graph is called a hyperbola. Here, its domain is every x not equal to 0, because at 0 it flies off to infinity, and the vertical line doesn't meet the graph at all. Its range is every value except y equals 0. Again, this horizontal line doesn't meet it at all. So this is a curious kind of function in that it's undefined for x equals 0 and goes to infinity. So infinities are involved with this. Here's a graph of y equals 2 to the power x. It's called an exponential. And its domain is all x's, all real numbers. It's always defined for any x. But its range is only positive numbers. It only has positive values. This is the graph of log base 2 of x, the logarithmic function. Now these two graphs really look like each other if you flip to the diagonal. This is for good reason. These are what are called inverse functions. They undo each other. Now this, in contrast to this, its domain is only positive x, but its range is all y. Here are some examples. Here we have f of x is 2x minus 3. Find f of 3 and f of negative 1. Now, it's a simple matter of putting in the 3 or the negative 1 in for x here and here. F of 3 is twice 3 minus 3. That's 6 minus 3, which is 3. F of negative 1 is twice negative 1 minus 3. That's negative 2 minus 3. That's negative 5. Here we have a function h of x equals 1 over x plus 3. It takes x, adds 3, finds the reciprocal. Find h of 5 and h of negative 2. H of 5, you plug in 5 for x. 1 over 5 plus 3 is 1/8. H of negative 2 is 1 over negative 2 plus 3. That's 1 over 1, or 1. Oh my goodness. Do we do this? We've done linear functions before, right? Yeah, that was it. Yeah. Find a function whose graph is a line, so it's y equals ax plus b, with a slope of 5 and through 0 by negative 3. Okay, great. The slope of 5 is y-intercept negative 3, and the slope-intercept formula is y equals 5x minus 3. We've already been dealing with some functions already. Find the equation of the line through 1 by 7 and negative 2 by 1. Okay, we're back to linear functions. Okay, if it's a line, it has a slope. The slope is a change in the y values divided by the change in the x values. 7 minus 1 over 1 minus negative 2. 6 over 3 is 2. Use 1, 7 in the point slope formula, so y equals 2, that's the slope. Comes x minus h, in this case it's 1, all that plus k, which in this case is 7. We distribute the 2 and simplify, get y equals 2x minus 5. So the line is the graph of this function. Find the equation of the line through 1 by 2 and is perpendicular to the graph of y equals negative x over 6 plus 1. Now this line, this is the equation of a line with a slope of negative 1/6, negative 1 over 6. And the perpendicular has negative reciprocal slope. It'll be negative 1 over negative 1/6. Ones cancel, reciprocals cancel, it's 6. So the line that we're looking for has a slope of 6. It goes through 1 by 2. So y equals 6 times the slope times x minus h, 1, all that plus 2. And after distributing the 6 and simplifying, you get y equals 6x minus 4. If f of x, and here we have the Fahrenheit centigrade or Celsius conversion. Centigrade degrees, I prefer calling it centigrade, but I'm told the PC name for it is Celsius. is 5/9 of the Fahrenheit degree minus 32. Now, if F is between 68 and 77, what are the bounds on C? Always start off with F between 68 and 77. Now we're going to build up C by taking F, subtracting 32, and multiplying by 5/9. So here, we subtract 32 throughout, from this, from this, and from this. And then this becomes 36, this becomes 45. So F minus 32 is between 36 and 45. Now let's multiply by 5/9 throughout. 5/9 36, 5/9 F minus 32, 5/9 of 45. 5/9 of F minus 32 is C. That's the definition of the function. And 5/9 of 36 is 20, and 5/9 of 45 is 25. And so therefore, between 68 and 77 degrees Fahrenheit is between 20 and 25 degrees Celsius. Okay, that concludes section 2.5. Let me stop the video, stop recording.